Hello. In this video, I'm going to walk you through my Express REST starter project, which is available on my GitHub page. Okay. So a little about me, I'm a software engineer at Edmunds.com, currently working on the CarCode project, which is a service that connects car shoppers with dealerships. I'm a full-stack developer specializing in JavaScript for both backend and frontend. You can follow me online on Twitter and Instagram as your web dev guy, or on GitHub and LinkedIn as Abraham Cuenca. If you're watching this, then you may already have an idea of what Express and REST are. But just in case, Express.js is a web application framework for Node.js. REST, or Representational State Transfer, is a way for two computer systems to communicate over HTTP. Now, you may be asking yourself, why do we need this project? Well, whenever we create a new project, we typically go through a list of chores that we need to complete before adding our custom code. These tasks usually include setting up a data store such as MongoDB, Postgres, or MySQL, adding the ability to log in and authenticate against a protected API resource, adding developer documentation for developers that are consuming our API, and setting up continuous integration and continuous delivery pipelines. For most projects, starting out with a NoSQL database such as MongoDB is the best choice. MongoDB allows for a flexible schema that takes shape as your project matures, while using a relational database such as Postgres or MySQL is less flexible. A relational database usually stores relationships between tables through primary and foreign keys. So if you're adding or removing a table as the application needs change, essentially you're requiring more planning and care. And since we kind of don't want to have that complexity starting off, this is basically the reason why I chose MongoDB for this project. If you want to use Postgres or MySQL, you can definitely update this project to do so. So taking a look at the project, in the main directory we have our package.json, configuration files for Prettier, Travis, Jest, and NodeMon, our .env file for configuring our environment variables in development, and our swagger.json, which represents the documentation for our API. In the source folder, we have our server.js, which serves as the entry point for our project, along with its test file, and we also have two folders, core and routes. In the core folder, you will find our shared code. These are things such as the config files for the application, any constants that we'll have, and services that we create. For source/core/config app, we see here that we have all of our environment variables which will be used throughout the application. So using .env, we first use any environment variables that are declared in the system. If we don't have any, then we're going to check the .env file that we've created. And if that isn't found, if we don't have anything declared there, then we're going to fall back to these default values that we see here. So in this case, MongoDB /localhost/express REST starter will be used for our database URL, and our test database URL would have basically the same path with -test at the end. We default our project to use port 8080. We want to sign our JWT keys with secret, and we want to make sure that our JW keys expire after 7 days. Now you can copy the .env example file that we've provided here, and just copy it as .env and set your own environment variables. So whenever you're developing locally, if your MongoDB URL happens to be different, or the database name is different, this is where you'd want to change it. And of course, once you're actually deploying this to a service like Heroku, you can configure your environment variables for Heroku in your project settings. So that would be your actual production database, etc. Now in this source core DB, or rather source core config/db file, we have the configure options which we pass to Mongoose to connect to MongoDB. Next, looking at our config constants, basically we have two folders here. One folder stores our custom error objects, while the HTTP codes is just a map of our HTTP codes which we'll return throughout our application. And for example, here we have an object that will return 2 keys, one of the HTTP codes, or one for the HTTP code rather, and the other with a reason for that code. Any other responses that we want to send would be collected here, and if in the future the shape of our errors change for some reason, maybe we want to exclude or include more data, and we only need to make this change here once, and we don't have to go hunt this down in the project. So in this constant/HTTP codes, we basically map all of the codes to a phrase so that we can easily look these up, and also it makes it easier to read in the documentation, in the code reviews. And for our source core errors file, this is basically a service, an error service, where we're going to combine our objects, our error objects, and our HTTP codes into reusable methods. So basically, for example, or rather, if an endpoint expects a password in the request body and the password is less than 10 characters, then we can reject that request by sending back the validation error. And for the message in the location, we can basically say that the length was too short and the location was a password field. We're going to see an example of how this is used later on. So taking a look at the next folder in our source, we have the routes folder, and currently we have 2 in there, 2 folders. Each of these basically represent the resources and their endpoints. Now, it is a good habit to version your APIs so that you can maintain backwards compatibility with your clients. So anybody who's using an older version of your API can still use V1, while anybody upgrading to V2 will use any new features that you add. So in this example, what we have here is the V1 folder contains the database models, which will be used by the endpoint to create a user, and an object is passed to mongoose.schema, which describes all the fields for that particular object and any constraints for that field. So we have username with the type of string, it's required, and it's unique. So if those happen to not match, then we're going to get a rejection from MongoDB, and then we can handle that appropriately by returning a response, a validation error. The mongoose.schema returns an object to us when we feed it that object describing our schema. And basically what we do is we can add some additional methods to that object, which will allow us to serialize the user. In this case, the serialized user would emit the password, and because we don't want to return the password to the client when they make a request for this user. And we also add some methods to validate the password by comparing it with the stored hash. And then we have a static method, which is called hash password, which uses bcrypt to hash that password before storing it. So we're going to see how this is used in the user's routers coming up. Now for the source routes/users, in this router we create a post endpoint which accepts the request body with the key value pairs for username, password, and email address. Now optionally we can send in a first name and last name, but these are not required fields. And next what we do is a little bit of validation, and that includes checking for the required fields, ensuring that the fields received are the correct data types, ensuring that we have no white space for username and password fields. And we also check that the field size, the fields are within the right size constraints. So for example, we want to make sure that our passwords are larger than 10 characters, but no larger than 72. Now, once we have a validated user object, we check the username against the database to make sure that we aren't having any signups where the username is already taken. So if the name is taken, then we respond with a validation error. And you see how this object came in handy here, where we're basically reusing this validation error and passing in the message of user already taken and the location username, so they know which field in their object that they gave us back contains the error. And if the name is not taken, then we hash the password and create a new user using the create method, which is provided by Mongoose when we created that user schema. Now, with a newly created user, we can respond with the 201 created, and return a serialized version of the user, again omitting the password, but with any other information that we want to send back. If for some reason we run into an unspecified error or we can't connect to the database, then we just return a 500 internal server error response. For our auth router, we also have a router.js, index.js, and test.js similar to the user route, but instead of a models.js, we have a strategies.js file. Take a look at how that works. In the strategies.js file, we define the ways that we will authenticate a user via passport.js. So we want to have both a local strategy, which accepts a username and password and looks up the user in MongoDB, and a JWT strategy, which will validate an auth token passed in through the authorization bearer header. The router for the auth route is a lot simpler than the route we saw for the users route, even though we have two post endpoints here. First, we create a method called createAuthToken, and what we're doing with this method is basically we take a user object, and this user object is that serialized user from MongoDB, and we create a token that is signed with the JWT secret, the keyword that we use, or the password or string, and then we set the JWT subject to be the username for that user. Now, the first endpoint, /login, uses the local auth middleware, which basically says it accepts a username and password in the request body. Now, if that middleware goes through its motions and finds the user and returns it to us, then we accept that response of that serialized user and call our createAuthToken function, and then finally we return that in the JSON response body. Now, the second post endpoint, which is /refresh, will exchange a valid token that's not expired from the authorization header for a new token. So with our database configured and our authentication strategy set up and our routes declared, we can now put together our entry point or server.js. And what we do is we start by requiring all of our dependencies and importing our config values and routers. We also import our swagger.json file, which again contains the description to our API. In the next section here, we create our Express app. We use the Morgan middleware, and we specify that we want the combined logging format. This format lists each request and the user agent that made the request, and that's my preferred format. Now, we also add the Helmet middleware, which basically sets various HTTP headers to help make the Express server more secure. And these includes headers for protecting against cross-site scripting attacks, setting content security policy headers, removing the Powered by Express header, and a few more. Now, we create our own middleware right underneath where we're setting some headers ourselves, and this is really more to show that this can be done. You can just use Helmet as well. And Helmet can take some configuration, but what we're doing here is we're basically saying that we're going to allow all origins to hit this endpoint. We're only going to accept content type and authorization headers, and allow get, post, put, patch, and delete methods. If we happen to receive an options method, then we just respond with the 204. Afterwards, we tell Passport to use our local and JWT strategies, and we map our user router and auth router to their appropriate paths. For our Swagger documentation, we make that available actually at the API/v1/API-docs. Now, maybe you want this to route to /docs or /API docs. I mean, we can change that here, but for this example, we set it at this path. Okay, so in order to ensure that protected endpoints are working as expected, we've created a simple endpoint here which will return an object containing the data hello world. And to ensure that we can access the public endpoint, we also have an endpoint at API/v1/auth, which responds with the status code of 200 and just a plain text OK. Now finally, for any routes that aren't declared explicitly, we'll simply return a 404 with an object that has the message not found. At the end of our server.js, we have methods for running our server, closing our server, and we also export both of those along with app so that we can use them in our unit tests. Now, every service in core and routes have tests. So by default, we always want to have tests for everything. Our server.js also has a test that goes along with it. So because you want your code to be portable in the sense that I can copy this folder and reuse it everywhere, that's why we're kind of bundling the index and the router, the model, and test all in one, for example. We keep our tests together with the code that it's related to, as opposed to having just one test folder where we dump all of our tests. Now, the tests are written using jest and supertest. And for example, in the server.test.js file, we import our server and any configs required for testing. In this case, the test underscore database underscore URL and JWT underscore secret. Next, we create our describe block, and within the describe block, we set up our tests with a before all and after all methods. So these two methods ensure that we start and stop the server for every test. So each test will have these. And between each test run, we also have a before each and after each that will run. And this basically generates a new user each time using the Faker library. Because we're making requests, the server we need to the server basically, we need to make async calls for each it block. The first test in this test suite confirms that we can access the health endpoint. So by calling this, we're expecting to receive the 200. We're not expecting any errors, and really if it's not a 200, there's a bigger problem, so this test should pass easily. The second test confirms that we can receive, or that we will receive rather, an unauthorized error when we don't provide an auth token. And the last test creates a mock auth token which contains a signed valid token, and we make the request by passing this authorization header with the bearer token. So because it is a signed token and it's valid, the API will respond with 200 and hello world. Next, we're going to go ahead and test our code. So before running our project, we're just going to run really quickly npm test. And although we can mock the MongoDB database for the tests, we actually want to make sure that we can connect to the database. So before running this, make sure that you have set up your connection strings correctly. Now, we'll just do npm test. Okay, so we have our message that the app is listening on 8080. It's making all of the requests to our auth login and auth refresh endpoints. Alright, and we have here, we can see that all the tests have passed and that our code coverage is at an acceptable level. Alright, npm start. There we go. So we can see here that we have our endpoints listed. Our health endpoint, which if we click try out now, we can see that we can expect the response of 200 with OK, and it'll be a text/plain. Here's an example of what this would look like, and the schema just says it's a string. So by executing this, the response that we get back is a 200 with OK, and here are the headers that we received. So as you can see, there's no powered by Express, so that helps with some security so that anybody that knows you're using Express doesn't try to exploit any vulnerabilities that may exist. Now, here for our protected endpoint, you may notice that we have this little lock. So the two responses that we expect from this endpoint would be either a 200 with data/hello, and again we can peek at the schema here, and or a 401 unauthorized request. If we try this out and execute it, because we don't have a token, we do receive, in fact, indeed, the 401 unauthorized. So let's go ahead and create a user using our users endpoint. And here we see that an example of what to send through would be this object here. Schema says that we have to have a username which is at least the length of 1, password with between 10 and 72, an email address which is required, no greater than 254, and optionally first name and last name. So what we can expect back would be a 201 user created with our serialized user. If I make a mistake, then we'll get a validation error with code 422. In this example, the username was missing, so that came back that way. But because we're wanting to create a user to test our protected endpoint, what I'll do is I'll come in here and we'll create a user named Bob. This will be Bob at example. Bob Robinson. Sure. So now let's go ahead and click execute. Okay, and we see that our object came back with a 201 response. And now that we have a user and we know the username and password, we can actually request our auth token. So let's log in with this and we'll do try it out. This was Bob. I know I just copied it, but I'll just type it out. And for this endpoint, we can expect either a 200 or a 401, and the auth token would resemble something like this. So let's go ahead and execute this. There we go. We get our response with our auth token. And by the way, we can actually verify or see the contents of this token by going to jwt.io and pasting in our token. There you go. You can see it's Bob Robinson. And the only thing here is it says that there's an invalid signature, and this is because we have to add our secret key. So once we give the appropriate key, then we can say that the signature is valid, and that means that this token we can now pass into our protected endpoint, and we do that in Swagger by clicking the lock, pasting in our token, and clicking authorize. And now when we make this call, we see that we received 200 with a response of hello world. Now, the last test is just to make sure that we can get a new token. So again, here we have the issued at 307, expires at 107. And what we're going to do is just exchange this token for another token. So let's try that out. Oh, actually, yeah, the token's already there. And let's go ahead and execute. Okay, and this brings us a new token, which we will copy here. And we'll duplicate this tab, but pass in our new token. And we can see that this expires at 188 and it was issued at 388. So, yep, that's the gist of this project. And our health check, I think we already tested this one. Okay, so there you have it. From this starter code, basically you can use this for any project that you're working on, including either a hackathon, an MVP, or even a greenfield app. For my own project, I'm actually going to clone this, or fork it rather, and create a GraphQL version so we have both an Express and GraphQL. Now if you found this useful, feel free to hit the like button and leave any comments down below. Now don't forget to star this repo in GitHub if you find it useful, fork it and use it for your own projects. And if you want to contribute, you can also submit a pull request or open any issues, but most importantly, have fun and keep coding. Thank you.